All right, let's tackle the single most common ticket you'll ever see at a help desk. My PC is slow. 8 times out of 10, it's either a runaway process eating your CPU or memory pressure choking the system. And by the end of this lesson, you'll diagnose either one in under 60 seconds, whether the user's on Windows, macOS, or Linux. We'll walk through processes, the memory model, the cross-OS tools, and how to kill what's stuck. Let's get into it. First piece, processes, deep dive. Every process has 2 numbers, its own PID and a PPID pointing to whoever spawned it. That makes a tree. Kernel boots init. Init launches your shell launches Chrome. And killing a parent usually takes the kids with it. Now, those processes live in states, running on CPU, sleeping waiting for I/O, which is most of them, honestly, stopped. Or the spooky ones, zombie and uninterruptible. Inside a single process, you've got threads, cheap little workers sharing memory. That's why one Chrome tab can light up all 4 cores. And zombies, a process that died, but its parent never checked the body. Harmless unless you've got thousands, then the parent's buggy. Piece 2. Memory. Here's the trick modern operating systems pull. Every app thinks it owns all the RAM. The OS hands each process its own virtual address space, then quietly maps it to physical RAM in 4 KB pages, or when RAM fills up, to swap on disk. And that right there is your answer to I've got 16 gigs. Why is my PC crawling? The OS is swapping, and disk is 50 to 1,000 times slower than RAM. Watch memory pressure. Green's fine. Yellow means tight. Red means you're already in trouble. And if it goes truly full on Linux, the killer picks a victim, usually a browser tab, and ends it. Windows and Mac are gentler, but the freeze tells the same story. So here's where theory becomes muscle memory. Same job on every OS. Open the viewer, sort by CPU or RAM, spot the hog, kill it. On Linux, it's top and kill. On Mac, activity monitor, or the same kill command. On Windows, Control-Shift+S and task kill. Memorize the row for your daily OS cold, and just glance across when you're sitting at someone else's machine. That's literally the 60-second diagnosis we promised. 4 steps, 3 toolkits, 1 workflow. Let's go deeper on those toolkits. On Windows, Task Manager is your 90% tool. Control-Shift+S, jump to processes, sort by CPU or RAM. Right-click, End task. On Mac, Activity Monitor adds something special, a memory pressure graph that goes green, yellow, or red. The single fastest way to know if a Mac actually needs more RAM. On Linux, top is everywhere, but install htop the moment you can. Colorized, mouse-friendly, F9 to kill. And then ps-aux, pipe through grep, is your universal fallback. Same command on Linux, macOS, and WSL. Learn 1 pair cold, and the others become a 5-minute read. Once you've spotted the problem process, you need to end it. And there's a right way and a wrong way. Killing a process is really just sending it a signal. Start with sigterm, the polite tap on the shoulder. Kill 1234 on Linux or Mac. Task kill PID on Windows, or just end task in the GUI. That works for 90% of stuck apps. Only when it ignores you do you escalate to sigkill. Kill-9, taskkill/F, force quit. It's instant, but the app can't save a thing. And if you see a process stuck in D state, uninterruptible sleep, even kill-9 won't touch it. That's a hardware or disk issue, and your only fix is wait it out or reboot. Now let's put it all together with 4 real tickets straight from the queue. Ticket 1, Chrome eating 50% CPU. Hit Shift+Y. Inside Chrome, find the rogue tab, close it. Ticket 2, Mac fan screaming at idle. Activity Monitor usually fingers MD, stores, or photo analysis, both temporary indexing jobs. Just let them finish. Ticket 3, a Linux server, killing apps, free-h, and DMESG confirm it, then top sorted by memory finds your leak. And ticket 4, that 30-second freeze is almost always swap thrashing. RAM's full, disks pegged at 100%, so close apps or add memory. Same pattern every time. symptom, tool, fix. Before we wrap, lock these 12 terms into memory. They're the language every log file, ticket, and senior tech will throw at you. PID and PPID identify processes and their parents. Threads are cheap workers sharing memory inside one process. A zombie is just a dead process, waiting to be cleaned up. Virtual memory, swap, and the Windows page file are how your OS fakes having more RAM. And when that fails, you get kills on Linux, memory pressure warnings on Mac, or full-blown thrashing. Finally, SIGTerm asks nicely, SIGkill, that's kill-9, is your last resort. Now, with that vocabulary locked in, let's torch the 5 myths that cause most misdiagnoses. 1. 100% CPU isn't broken. Check what's using it. Video encoding pegs the CPU, and that's fine. 2. On Linux and Mac, free RAM isn't the goal. Cached RAM is making you faster, so look at available, not free. 3. More RAM only helps if you're actually memory pressured. Check first, don't just throw money at it. 4. Kill-9 is a last resort, not a first move. Try a graceful kill and wait. And 5. Closing background processes rarely helps. Fewer startup apps and fewer browser tabs do. Don't be the tech who kills Explorer exe to speed up Windows. And that's lesson 31 in the bag. Processes locked in. You can read a process tree, judge memory pressure properly, sort by what's actually hurting, and kill cleanly before going nuclear. Next up, boot and login. What actually happens between the power button and your desktop, so when a machine won't start, you know exactly where the chain broke. One OS lesson plus the capstone left in stage 4. See you in lesson 32.